Question 2, Part C. Let P of x equal x plus 1 in brackets times x minus 3 in brackets times q of x plus ax plus b, where q of x is a polynomial and a and b are real numbers. The polynomial P of x has a factor of x minus 3. When P of x is divided by x plus 1, the remainder is 8. Part 1. Find the values of a and b. And Part 2. Find the remainder when P of x is divided by x plus 1 in brackets times x minus 3 in brackets. The first factor we need to consider is that P of x has a factor x minus 3. This means x minus 3 evenly divides P of x, leaving a remainder of 0. And by the factor theorem, this occurs when x is equal to 3. In other words, P of 3 is equal to 0. So the remainder component of the right-hand side, which is ax plus b, that equals 0 where x is equal to 3. Hence 3a plus b equals 0 when we substitute 3 for x into the remainder component. And then rearranging this equation to make b the subject, we get b is equal to negative 3a. Let's call this equation number 1. The second factor we need to consider is that P of x has a remainder of 8 when divided by x plus 1. So by the remainder theorem, P of negative 1 is equal to 8. So substituting negative 1 into the right-hand side of the polynomial equation, we get P of negative 1 is equal to negative 1 plus 1 in brackets times negative 1 plus 3 in brackets times the quotient q of x plus a times negative 1 plus b. Now this term here is equal to 0 because we have negative 1 plus 1 is equal to 0, which multiplies everything else. So this entire expression here, from here to here, is going to be equal to 0. So what we're left with is 8 equals negative a plus b. And that equals negative a minus 3a. Now we replace the b with negative 3a from equation number 1 here, which is how we get this expression here. So we have 8 equals negative a minus 3a. Now we have like terms, so we get negative 4a here. So negative 4a is equal to 8. Dividing both sides of the equation by negative 4, we get a is equal to negative 2. Now if we go back to equation number 1, and if we substitute a equals negative 2 for a here, we get b is equal to 6. Therefore, a is equal to negative 2 and b is equal to 6. Since P of x is expressed in the form d of x times q of x plus r of x, where d of x is the divisor x plus 1 in brackets times x minus 3 in brackets, q of x is the quotient polynomial, and r of x is the remainder, negative 2x plus 6, since we found the values of a and b in part 1, therefore, when P of x is divided by x plus 1 in brackets times x minus 3 in brackets, the remainder is negative 2x plus 6. Now, another way to look at this, if we model this using polynomial division, our P of x is the dividend. Our divisor is x plus 1 in brackets times x minus 3 in brackets. Now, performing the polynomial long division, our quotient would be q of x, but there'll be a remainder down here, which will be ax plus b. And in part 1, we found the value of a, which was negative 2, and the value of b, which is 6. Therefore, when P of x is divided by x plus 1 in brackets times x minus 3 in brackets, we get the remainder negative 2x plus 6.